This will be just a short test of the ZVS induction heater. I just want to see what happens with metals other than iron. We know that the graphite crucibles work. As we tried this one yesterday, and even on 24 volts, the thing would draw way too much current for me to be able to drop it in the work coil. This littler graphite crucible drew about 10 amps at 24 volts. I don't know, maybe 14. Anyway, in that vicinity. But in the past, I've not had much luck with other materials. So let's see what happens with copper, tin, and solder. Okay, 2 amps for the fan and the pump. Set on 24 volts. Now we're reading 4 amps. That includes fan, pump, and idle current for the circuit. Now I've just got some solder, some 4060 solder. I'm just going to stick it down the hole and see if the current increases at all. Boy, I can barely see it on the meter. But it does get warm. A little bit. Here's a piece of copper tubing. 24 volts. I stick it in there. Boy, I maybe 1 amp. Really can't even tell if it's heating at all. Let's see what happens here. I'll put this in here, and it says 59.56, and I'm counting down with my timer over here. See if it even gets warm to the touch. That's just 1 amp. In 10-15 seconds, maybe it's increased a couple of degrees. Let's give it a whole minute. Get out my handy dandy temperature meter here. Really can't tell. Been about a minute. It's maybe 110 degrees. So it heated the copper just a little bit. Sorry about that. Okay, next I have a bar of pure tin. And notice it's physically bigger than either of the other samples too, so it's going to take up more of the work coil. Maybe 1 amp. That says 58.21. We'll give it a whole minute. That's my furnace for the room coming on. Again, it's about 1 amp. There's a minute. It's 120. Yep, so it warmed up a little bit. Now, just for comparison's sake, we did this yesterday. This is on 24 volts now. We'll put this 1/2-inch square bar of iron in, which is about the same cross section as the tin. Remember the tin, we got 1 amp of current, right? Okay, so here we are, 50 on the meter and counting down. So we went from 4 amps to 15 amps almost. $220 degrees. What did I say? 50 something? $16 amps. $250 degrees, but this isn't all that fine a tester. It says 300 degrees, 360, 370, but it's getting hot, and again it's drawing 16 amps. So if I touch my thermocouple to it here, it's reading 180 Celsius, 200 Celsius. If I shade the thing, I can see a vague glow starting. Still 16 amps. .300 Celsius and so on. So anyway, that the ferrous material obviously heats up a lot more. Okay, so that's that test for the moment. Now we're going to rerun the same test at 36 volts. So cooling is still on, drawing 2 amps. Switch to 36 volts. Turn on the power. Now we have 5.5 amps of total system current. We'll stick our piece of solder in here and see how much the current increases. About 1 amp again. So 48 on the meter. There's after 10 seconds. Almost too hot to hold, so that heats up. Okay, so now I'm going to try the copper tube. And here, 23 on the meter. 23, so we'll see what happens in 10 seconds. And again, about 1 amp. 13. That's getting warm. 07, so we'll give it a whole minute. But still, it's just like 1 amp, maybe a little more than 1 amp. But the point is, it's 1 amp at half again as much total wattage because we're running on 36. So that's maybe an interesting point right there, huh? Now I forgot where I was on my meter. 20 something? 23 maybe? In other words, I was going to heat it for a minute. A little over too hot to hold. I'd call it maybe 140, 145 degrees. It is copper, so, so it transfers a lot of heat upwards. Now we'll go to our piece of pure tin, which still from the last test, it's just one end is a tiny bit warmer than the other. I'll put the cooler end in again. And we have 50 seconds on the meter, on the timer, and that went up about 1 amp again. But again, remember that if it was 1 amp at 24 volts, that's 24 watts. 1 amp at 36 volts is 36 watts, so it's half again as much power. And again, I forgot my number, 50. So we're going to let it be in there for 1 minute. So we're waiting to see what happens here. And this is silver, you know, so this kind of a temperature meter isn't very good for things that are shiny anyway. Besides, it's only got an 8-to-1 field. It says 89 degrees. I don't think we can put any credence in that. We're after 50 on the timer there for a 1-minute test. $53, $52, $51, $50. And it's probably 160 or 170. It's solid. The copper was hollow. So I think this is really soaking up a lot more heat. One of the reasons I wanted to do this was just to see if the guys that are using it for solder pot could directly heat this material, or whether it was the crucible that was heating the solder they were putting in them that was creating the heat. But that would heat up eventually. Okay, so now we'll go to this bar of steel, and again we got 5.5 amps idling current. 2, 1, 50 minutes, 0, 21 amperes. Okay, so that's 20 times 36. That's what, 650, anyway, 600 and some watts. So we're putting a lot of power into that baby. And I've got a 20 amp circuit breaker over here, which hasn't popped yet. We're going to heat this one for a minute. Actually, the current's increasing. Now 23, maybe almost 24 amps. That's interesting. I haven't had that happen. And it's glowing. You see it glowing. Three seconds to go for a minute. Now the temperature's dropping, or the current's dropping quickly, down from what I say, 23, 24 amps, 18, 17, 16. That's as the main part of it that's getting heated goes beyond the transformation temperature, and the little dipoles in the magnetic structure have quit dipoling. But clearly that is getting a lot hotter. $14 amps. The temperature meter that I stuck in there is still rising pretty quickly. 430, 460 Celsius. This is Celsius now. 14 amps. Forgot to turn my voltmeter on. Didn't think I'd need it. Maybe I do, maybe I don't. Just saw an air bubble go by in the pump. 540. 13.5 amps. More of it is becoming red hot, so a longer length of it in there is becoming non-magnetic. 553, 554, climbing pretty slowly now. Oop, I made a little better contact. 585, 600, 613, 624, 625, 629, 630, 632. It's climbing pretty slowly now. 631, 632. That's about all we're going to get out of that. And it says 4653, so that's about 3 minutes plus that we had it in there. So I'm going to take it out of there, turn the lights off, just again to do another color check as long as we're here. Ta-da! So that's that. And as long as I'm at it, I think I'll tip the camera forward so you can see the color in both the dark and the light. Okay. And the color in the dark. And it only looks orange to me in the dark even. I'm going to do one more color check with incandescent light from this flashlight now on it. I don't know if there's anything to be learned from that or not. And we'll shut him off. Now the whole bar is just about too hot to hold at the far end. So that's the end of my test for the day with different metals. Let me just take a quick look here at what our battery voltage did. And I don't know if you can read it or not, but it says 36.9 with no load. But I'm going to turn the power back on and stick this back in and see what the batteries have gone to under a load. And they're actually down to 32.4. Okay. Power's off. Voltage sensing switch in the middle. Pump and fan are on to cool the work coil and the work. I know the work has been out of there for a little bit, but the components are nice and relatively cool. I mean, under 110 degrees Fahrenheit. Okay, that's it.